Thank you. Thank you once again for providing me the time and opportunity to speak in the FICC conference 2021. My name is Naresh Chetri and I'm a PhD student at UMSL. And today for this session, so my topic is blockchain technology for improving transparency, and the focus is for the citizen trust, work, or the research. I have tried to focus for the public service delivery, and obviously the public service delivery means the two things that comes first, that is transparency and the trust. So my table of contents that start from the background and then move towards the introduction and a little bit of literature review and the methodology used, and then trying to sum up with the results and finding along with conclusion and future work. And after the future work, I have listed all of my reference, the question answer session, if you have any questions or doubt. So first of all, I want you to tell about the feasibility chart that have been used over here. That means by nature, the blockchain cannot be applied to all the system as a modular off-the-shelf solution. That means it cannot be the solution for all problems. But this feasibility flow chart of figure number 7 that clarifies the usefulness of the blockchain. That means if the blockchain is not useful for the project, and then it cannot be feasible either. So that's why it's a flow starting from the need of the database. So there is the need of the database, and ultimately it will help to find if the blockchain solution is needed or the blockchain solution is not needed. I mean, that goes when it is yes, and when it is no, then it answers to the need of the blockchain. That means the characteristic of the blockchain we will discuss that have added the value over here are disintermediation, auditability, the transparency, the cost saving, the immutability, the remote participation, and the verifiability. So there are three types of the feasibility I have discussed. The first one is the economic feasibility, and then the technical feasibility, and the socio-political. So to define the feasibility chart or how the blockchain is feasible. So now let us go and start from the background about the blockchain. So before going towards the background, so it all the way start down from the white paper of the Nakamoto, as you all know. So today, these days, the popular network architecture in all the areas is the client-server architecture. That means the client-server architecture, not the peer-to-peer. So we normally say the client-server architecture or the CS architecture. So where there is a central server that remains as a central hub, or the powerful computer that bears the capacity to control the overall transaction. That means that is a central server that controls all those things. So there are both advantages and the disadvantages of that central server. So the advantage is that the existing technology was possible by allowing the exchange of the information, and that is the information between the parties without the physical presence. Yeah. But the major drawbacks, we want to talk about the major drawbacks of this, the client server architecture, is that the major drawbacks comes because of the existing system, a risk of third party being compromised, that is the presence of the single point of failure. On the contrast to the client server architecture, the peer-to-peer architecture is based on the blockchain technology. So this peer-to-peer architecture, or normally we say peer-to-peer network, is based on the blockchain technology. That means the power or the authority that doesn't rest on the single computer, rather it rests on the all participants of the network. That means all the network means they are distributed, and distributed in the sense they are peer-to-peer nature of the blockchain technology that doesn't has the single point of failure. So that means no single point of failure. That means it use the renowned technology advancement like the hashing and the digital signature, the consensus mechanisms, and every computer of the networks control the every computers in the network. That means the absence of the third party has removed the single point of failure. Here, the presence of the third party that brought the single point of failure, but that has been removed over here. The blockchain-based technology on that means the POW consensus algorithm, that is the Bitcoin that operate on the 100% verification. Okay, so we normally say the 100% verification means everything is verified. So 100% verification and 0% trust. There is no trust in the virtual world. When coming to the introduction, the two figures, so that I already talked about the client server model. Yeah, that was the previous. That has been used today is the peer-to-peer model in comparison with the client server model. Simple blockchain is a interlinked sequence of the blocks. Yeah, that means the block 2 contains the hash of the block 1, and block 3 contains the hash of the block 2. It's shown in the figure. This way, all the upcoming blocks over here, the upcoming blocks are linked with the previous block. The interlinked nature of those blocks and the consensus algorithm makes it immutable and tamper-resist. That means here we normally talk about the two different models of the blockchain that are popular nowadays. One we call the public, the public, or we say the public blockchain, and another we also say public as a permissionless, because the example is the Bitcoin, the public blockchain, and the another is the private. Yeah, so private blockchain, so is normally the permissioned one. That means, in contrary to the public blockchain, the permission blockchain or the private blockchain are owned by certain organization or the group of the stakeholder. That means this nature of the distributed technology result in the simplicity and time effectiveness of the operations that ultimately leads to the increased efficiency compared to the public blockchain. So several projects and several people prefer the private blockchain when it comes to security, personal things, in comparison to the public blockchain. Going towards the literature review, so I have pointed several things about the traditional one, the digital ID management system. So say the digital identity management systems. So the Kong and he, they define the blockchain as the distributed database that anonymously maintains a continuously growing list of public records in the units called block. That means they try to secure from the tampering and revision. Whereas the Etroji described it as an irreversible and tamper-proof public records for documents, contracts, property, and assets that can be used to embed instruction with very wide range of application. Yeah. So implementation of the blockchain that comes in several public services. So some of the public services focus is about the voting. Yeah. And we normally say the land reform. Another is the land reform management, and another one is the supply chain management. Obviously comes under the food supply and so many things. A part of the management, of course, the supply chain, and also the another thing where the people are so serious about transparency and the trust is the healthcare. Yeah. So that has proved the existence of the great potential of reforming and transferring the service delivery. And it is also argued that the open blockchain is best understood as a possible information structure that, given its universal and evolving, and also the open and transparent nature of the public blockchain. The methodology, we have compared here the two things. So here you already see the traditional, the previous slide explained the traditional based identity management system. And this one we have tried to explain the blockchain based identity management system. That means the identity management system that has been taken consideration during the explanation of the traditional versus the blockchain based. So the review of literature regarding this DLT, I mean the distributed ledger technology, the blockchains that have meet to the objective of the research projects suggested here. When it comes to the blockchain-based existing system, there is the ability of the blockchain-based technology to eliminate, that means to eliminate the need of intermediates, means no middlemen, so no intermediaries. So here we have an example of the Alice and the Bob, which is very popular when we claim the identity to identify that it exactly the message sent by the sender is exactly the sender or not. So blockchain technology is proving a promising technology to take the threats of the cyberspace. So many threats in the cyberspace where we need through the 100% transparency and disintermediation, and it also consists of the interlinked block that are linked together by the cryptographic hash. So as we see with the previous figure, so the cryptographic hash, so interconnect, which is difficult to tamper. Tamper means nobody can change in the middle. There comes the concept of the smart contract. That means normally that is the built upon the blockchain. It is a pre-written laws in the form of the computer code. Yeah, so several programming language in form of computer code, and that is stored and replicated on the blockchain. That is the smart contract, and that is executed and run by the network of computers that are running the blockchain, and that can result in the updates to account the results and the finding. So there are several results and the finding presented over these projects. The first one, we try to compare between the anonymity and several features like the transparency, immutability. When we go through the statistics, it is found that the 67%, normally the 67% of the Americans worried means about what they are worried. Normally 67% of the Americans are worried about their electronic machines will get hacked or manipulated, about the tampering with the paper ballots. Also, 75% American trust their vote will be accurately counted with paper ballots, while 67% trust vote to be accurately counted using e-vote. That means with blockchain-powered services that has the use to control their own data, and that also ensures the privacy. Blockchain-powered land records and the measure undertaken of Locksport and other companies like the IBM that has proved the importance of the employing blockchain technology in the public service delivery or in the public service domain. The proposed model is shown over here in the figure 9. That means the user is a citizen. We can see the user over here, and the application comprised of his or her credential recorded in the blockchain, and network is in the form of cryptographic secure identifiers. That means the citizen could use the country's backbone network to access the public services. That means with the help of this backbone network, you can access the services, and the important records of the public service are immutably recorded in the blockchain. We could ensure the transparency and trust which will be there in the absence of the third party that will prove the effectiveness of the public services. And when regarding the conclusion, so several conclusions. So I want to stress over here is the Estonian blockchain implementation framework. That means the Estonia was the first nation in the world to deploy the blockchain production system in 2012, and that service were backed by the blockchain, where the healthcare, property registry, the business registry, and the digital code and the state gazette. Since it has better the digital government system, the citizens were used to the internet-based services, and the government has employed the KSI blockchain. That means unlike the traditional digital signature approach, the use of the PKI means the public key infrastructure, that depends on the asymmetric key cryptography that use only one hash function cryptography, allowing the verification to be rely on the security of hash function and ability of the public ledger, commonly referred to as the public ledger is obviously the blockchain. So thank you. Thank you for listening me. So these are my references, and if you have any questions, please.